Okay, so today is a precursor to something that we're gonna do tomorrow. We're looking at tomorrow. What's gonna happen is we're gonna explain why we get the answers that we do down here. But for today, you're just gonna type them into your calculator and see what you get. Right? So just recalling some things from last year. Complementary angles add to what? There's a difference between complementary and supplementary. Owen?
180.
Which one's which? Complementary is what?
180.
No.
Inside.
No. Complementary.
Oh, no, it's outside.
No.
90?
No, I'll just tell you. Yes, it's 90 degrees. Yes. Complementary add to 90. So something like 44 and what would be the other one? 46, right? Would add to 90. The complementary. Or 10 and 80. Right? So those add to 90 degrees. And the supplementary angles, what do they add to?
180.
180. Those are like the straight line ones, right? So, who has their calculator handy? Okay, type in for me the sine of 30. What do you get?
0.5.
Oh.
Too slow, Sophie. What's sine on 150?
0.5.
Oh, interesting. Why are they the same? Owen?
They add 180 supplementary.
Oh.
Okay. What about the... Hey? What about the next one? Gabe?
0.700.
Wow, 0.707
7.
one we'll write down. Okay, what about the sine of 135? Gabe?
Same thing, 0.707.
Okay. What about the last one?
Go.
0.
Okay. 0. And what's the sine of 0?
0.
Huh. So, what do we notice about the pairs? Who wants to tell me that again?
They all are the same. They answered 180. I don't know. Who was
So when we add angles, okay, when angles add to 180 degrees, the sines of these angles are equal. Everybody okay? So that's us in the box there. That's just the mathy representation of what we just did. Okay. All right, let's go down. What about the cosine? Gabe?
So it turns into positive for cos 30.
What? I just need the number.
0.866.
Okay.
And for 150, it turns into negative 0.66. 866. Sorry, whatever.
Okay, what about the cos of 45?
0.707. And 135 is negative 0.7.
Oh boy.
Seriously. Did you know I had a dance battle with the mascot?
Cos of 180.
Negative 1.
Interesting. What's the cos of 0?
1.
Huh. What's going on there? Gabe?
It seems like the closer you get to 180, the more negative it gets, and the farther away you get from 180, it turns into a 1 positive, I guess. Because cos 0 is cos 0 to 3 is the closest you can get to
Okay, so that's an interesting observation. Did we see any numbers come out or any values come out to be greater than 1 or negative 1?
No.
No, or I suppose it'd be less than negative 1. No. So that gets at the periodic nature of sine and cosine. Even look at sine wasn't a good illustration of that. We shouldn't see any trig ratios that come out to be larger than 1 or smaller than negative 1. Okay, that gets at the nature of what the graph actually looks like, which is that's what we're building towards. Okay, so that'll come in the next few days. What we're doing today is just developing, we're like experiencing some patterns that are happening with these trig ratios, right? So when the angles add to 180 degrees, the cosines of the angles are the same numerically, but their sines are opposite. And again, there's a little bit of an algebraic representation of that.
Are we gonna need to know those math ones?
You will be responsible for the ratio, yes. Not the actual decimal numbers, but the actual ratios that those are produced from. You will need to know, and I will show you that. That's tomorrow. Okay? Like decimals come from somewhere. Where do decimals come from? When I use the word ratio, they're fractions. So you will be responsible for producing the fractions that create those decimal numbers, and then you don't need your calculator actually.
Oh, but will we need to know the math equations for them?
No.
That's fine.
It's just illustrating what's happening in there, right? A part of this test will have no calculator, just so you're aware. Particularly the trig ratio component will have no calculator.
Should I take our calculator and give back to us?
I'll give you a part A, and then you hand in part A, I'll give you part B. Okay, that gets at what I'm saying here. You're responsible for the ratios that correspond with each of these angles. Okay, and I haven't shown you that yet. That's what we're building towards. Okay, we're gonna do that tomorrow. Okay. So the trig ratios can also be defined for angles in standard position on a coordinate grid. Okay. So an angle is in the standard position under the following circumstances, right? When the vertex is located at the origin, okay, the initial arm is on the positive x-axis. Okay, so we're going out into the positive numbers on x. And the terminal arm can be anywhere in the Cartesian xy plane. Okay, Cartesian being xy it's just the Cartesian grid xy, right? And it rotates about the origin. And it can be located in any quadrant, right? So the angle is determined by the amount of rotation between the initial arm and the terminal arm. Okay, so the initial arm kind of stays in one spot, right? It's just the x-axis. It's a fancy way of saying the x-axis. And our angle is a measurement of how far I swing this terminal arm. Does that make sense? And what are the possible values for the terminal arm? A lot, yes, that's a right answer. Gabe?
Between like 180 and 0.
Just 180 and 0?
360.
No, because it's just between.
It could go all the way around, right? Where this is 0, and it swings all the way around to become 360.
Could it go past?
It could go past, I suppose.
So
You just keep adding. Like, what's 2 revolutions?
720.
That'd be 720. But it's the same. Nothing changes about your trig ratios. It just goes around twice. Like, it's not really.
Well, then couldn't it just be infinite?
It could be infinite, I suppose. Yeah, do you want infinite? Do you want to deal with infinity? No. Let's just be happy with the 0 to 360. What about I think we're gonna talk about this on the next page, but is 0 to 360 the only option?
No.
That's kind of what I said here. I'm just thinking about the next question. If I go in this direction, did I receive the direction I went in? Counterclockwise. So when I go counterclockwise, Those are positive angles. And if I go clockwise, come on, those are negative angles. So where's negative 90 degrees?
In the negative.
Close. Negative 90 degrees would be here.
Yeah, that's fine.
Okay, well, you weren't very descriptive. On the negative y, that could be anywhere. It could be anywhere.
Waves.
Everyone good? So that helps us fill in the back page. You turn the page over now. Okay. So, angles formed by rotating in a counterclockwise direction. Counterclockwise is positive. Okay. And if I go clockwise, you get negative angles. Okay, the directional arrow is important on these, right? Because it's indicating which direction you've gone, right? You don't necessarily end up in a different spot, but there's a difference between going, let's say this is negative, let's say this is negative 30 degrees. There's a bit of a, well, numerically it'll still work out, and you can prove, what is cool is I think if you did the trig ratios for this, that's positive 330. So why don't you entertain me for a second? What's, I don't know, do this sine of 330, see what you get.
Go, faster.
Equals what, sorry?
Bang. -0.5 and -0.5 about.
It's, sorry, just give me 330, what is it?
-0.5.
Okay, and the sine of negative 30? So like, from a ratio perspective, it doesn't change much, but it's important to tell whoever which direction you've gone in. Right? Okay? So, now I get to show you something cool that maybe some of you, well, most of you probably haven't seen. Okay? So we all like Pythagorean theorem, I'm assuming. It's not hard to use, which is maybe why some of us like it. But it actually came from somewhere. Came from somewhere you might not necessarily anticipate it coming from. I'm just gonna do something here. Watch this. Did you ask why? It's a very interesting question. I'm gonna tell you why.
Yeah, that's what I said.
All right, so the directional, okay, so we have defined the trig ratios in terms of sides of the triangle, opposite, adjacent, and hypotenuse. That's what those stand for. Okay, for angles in standard position, the trig ratios can be defined in terms of the coordinates of the point P, X and Y. That got cut off by the picture, sorry. That should be X and Y, not X and V on the terminal arm. So, any point on an XY Cartesian grid is going to have what? Any point. Not a trick question. What does any point that you've ever seen to date have?
X and Y.
An X and Y value. So this is point P, and point P has an X value and a Y value. Everyone okay? Okay, so set X value. what's x? Everyone agree? That's how I would get out to that point. I'd have to go in the, I don't know, whatever the point is. If it's 2, I'd have to go out 2 units in the x-axis. Does that make sense? In order to get underneath that point. And what's the other component of any Cartesian grid point? The y component, right? And so I'd need, would be another color, purple, I suppose. Come on. Everyone in agreement? Okay. Here comes the interesting bit. We've measured up some angle. I don't know what that angle is. It doesn't really matter for the purposes of this. But I measure up to the terminal arm theta degrees, right? So it's going to be positive or negative? Positive. Okay, so I have a positive angle. Okay. Now if that's my angle, and this makes this opposite, this adjacent, and this hypotenuse. Now, what shape is the red shape?
Circle.
Very good. What shape comprises the blue and purple?
Triangle.
Oh, interesting. You want to see something? Who knows the equation of a circle? No, actually, that's the
Radius.
circumference.
You know what I'm saying?
What's the equation of a circle? You do this in grade 10 analytic geometry.
R squared
Owen?
equals-
X squared plus y squared equals R.
X squared plus y squared equals r squared. Let me ask you something. What is this?
R squared.
No, it's not r squared. It's r.
Diameter.
It's not diameter. It's radius.
What? I thought the radius was around. Oh, that's circumference.
Triangles to be seen.
Okay, so there's a triangle inside that circle.
Wow.
And where do you think the equation for a circle has come from, or the equation of a triangle? We take the side lengths, square them, is equal to r squared. That's the equation of your circle. Also at the same time, we have been used to seeing wow for triangles. That's interesting. Okay, here's one more component, one more layer. Hey? Of what? I don't know. I don't know. Okay, here's one more component. What if I was interested in writing out the trig ratios for theta? What would I get? Remember, the trig ratios are going to be so sine of theta. What's the sine of theta? Gabe?
Y over R.
That's it, buddy. What's the cosine of theta? Remember, you're just using SOHCAHTOA, right?
X.
Okay, what's tangent?
What? Oh.
Is everybody okay? Straightforward enough? There's one more thing with that I'm not going to show you yet, but it's going to blow your mind when you see it. We're going to do some work with it. Okay, sorry, that's a little low. Okay, if we rotate the terminal arm around the xy plane, we would form a circle centered at 0, 0. And we know, I just wrote this down, so it's just defined by x squared plus y squared is equal to r squared. Okay? So we get our trig ratios. And subsequently, for any point xy, whatever it might be, if it's 5, 4 or 2, 3, you can find the trig ratios for any point along a circle. Right? And I can also find the reciprocal trig ratios. Right? So you can see sine corresponds with cosecant, cosine corresponds with secant, and tangent corresponds with cotangent, and you can see what happened to the actual ratio. It's the reciprocal. Right? Are we good? Any questions? Are we okay? So I can tell you right now, the next page is there's a question on your test pertaining to the next question. Just turn the page over if you're good. Okay. I need to draw. First thing I'm going to do with these questions, draw the point 2, 8. It's wildly important that you put this in the right spot. Where's the point 2, 8? Two 8 is going to be up here somewhere. I didn't say how I was scaling my axis. Axes might not be the best. 1, 2. Let's see if I can fit this on here. 1, 2, 3, 4, 5, 6, 7, 8.
Wait, you can make them different?
Y-axis can be different from the x-axis, yes. What happens when you plot a parabola and it's measured in hundreds of meters or tens of meters versus seconds? They'd be different axes. They'd be scaled differently.
Yes.
Are we okay? So that's the point 2, 8. Now, on the test, I will ask, this is like, again, in the interest of condensing the test down a little bit, I will ask you for all 3 primary trig ratios and all 3 reciprocal trig ratios that correspond with that point, which is what we're going to do. We're just going to do 2 of them now, but in any event, here's what we got. Okay, I'm not going to need that. So here, I'm going to draw the terminal arm. And this is theta. Everybody good? Okay. So that's part A done. I've drawn theta. And I have my triangle labeled accordingly. So my job now is to figure out what the trig ratio is for sine and subsequently secant. Oh, and secant. Interesting. Okay, let's do sine first. I'm trying to trick you with this one. Sine. Sine is what? And we agree? Sine is opposite over hypotenuse. Okay, let's try and fill that in. So sine of theta is going to be, opposite is 8. What's the problem?
You don't know.
I don't know the hypotenuse. It's r, right?
Can't you just find it?
You can just find it. Yes. How do you find it?
X squared plus y squared equals r squared.
R squared is going to equal x squared plus y squared. So r squared is going to equal 2 squared plus 8 squared. Should you ever get a negative answer for this?
No.
I'm just going to slow down for a sec. I'm not sure if people are following. Is everyone okay with how I'm going to find r? I need r in order to fill in the trig ratio. I'm going to find it using, that's just Pythagorean theorem. It's just in relation to circles now. Okay? So, should I ever get a negative answer for the radius? I can't have negative lengths. That doesn't make any sense. Right? So if you do get a negative length, you've got a problem. So fix it. Okay, likely what some of you, actually it might come up. It might come up, and it'll come up in the next question. So I'll bring that to your attention in a minute. Okay, so let's just find r. So r squared is going to equal to 4 plus 64. So r is going to equal the square root of 68. Now, something's going to come back here. Something from your past. Everybody ready for this? Sine of theta is going to equal 8 over square root of 68. For how many of us like the look of that answer right now? Square roots have names like, it starts with an R. Radicals. Do we ever leave an answer with a radical in the denominator?
No.
How do I get rid of it?
Make it a fraction.
Nope. You need to multiply by root 68 over root 68. Because that turns into Am I done?
No.
Okay, what else do I have to do? This is a lot of work. Didn't seem like it from the beginning of the question, but there's a lot of stuff going on here. And that's what's great about this course is you can look at it from two ways, right? Like this course is great from the standpoint that like you have many opportunities to show me skills from the past over the entire course. But at the same time, you're not escaping the content from the beginning of the course. It's not just like, here, I'm going to do it on a unit test and then the exam. This is a very, very like fundamental skill building course, and it's not going to go away. Jacob?
From the point of like 2-8 going down the x-axis, not in the middle, is it a right angle there?
Yeah, sorry, yeah, it's a right angle. You come straight down.
Then couldn't you solve for the third angle and then do sine laws to get the radius?
Why?
It's just not supposed to.
Why? You could, but why? And why would you use sine law in a right angle triangle?
That's fine, SOHCAHTOA.
SOHCAHTOA?
Just to find that hypotenuse.
You
Did I give you the same answer?
you don't know the angle. Oh, I see. You don't know the angles though.
You could find the third angle. Oh shoot, no, you don't know theta. I thought theta was a number.
Yeah, that's a fair question. You had me thinking for a sec.
Never mind.
Yeah, but you don't know the angle, so you can't.
Yeah.
You can't. So you have to use Pythagorean theorem to find that radius. Owen?
We always have to express a non so we can't use decimals for roots.
No decimals. It's always exact answers for this. Hence, this is like a question that'd be on the non-calculator portion. Okay, I'm not done. You guys gotta tell me what to do. They're both like. Why don't we start with reducing the fraction that's there, 8 over 68? That would be like the first thing I would expect, bare minimum. Like somebody should have said that by now. I can reduce 8 over 68 by a minimum dividing by 2, because they're both even. But-
two.
Does 4 go into 68?
17.
Okay, so okay, so what's it reduced to?
2 over 17.
2 over 17. Sorry, 2 root 68 over 17. Okay, what else? You got to do the radical too. How do you simplify that radical? Owen? Or not Owen? Gabe?
You could also divide it by 2.
I'm asking you to reduce that radical if at all possible. So I need a perfect square number that multiplies by something else to give me 68. Does that exist?
4 and 17.
Is it 4 and 17? So I have the square root of 4 times the square root of 17. Some of us aren't watching right now, and I'm not helping you at lunchtime. Don't waste my time. You're going to sit here and do nothing and sit on your phone in the middle of class? Then don't expect me to help you at lunchtime. Not acceptable. Don't think I don't see this stuff. 2 times root 4 times root 17 over 17. Everyone agree? So what do I end up with, the final answer? Again, you're expected to do this without there's no calculator, right? So you end up with square root of 4 turns into 2. And so 2 times 2 becomes 4 root 17 over 17 is the sine of theta. Okay, and the secant would be what?
Hypotenuse over adjacent.
So you did all the work here, right? You found sine. But which one goes with sine?
No,
Not secant. Cosecant. Cosecant's the one that goes with sine. So you need to find what? This is maybe a poor question. I'm not going to do this right because we're out of space. But I'm just bringing to your attention the fact that secant does not correspond with sine. Secant is the reciprocal trig ratio for cosine. So why don't we'll just tweak this question a little bit and just say, I want cosecant theta. Just to save ourselves some space because we're out of room. Okay, so the cosecant of theta is going to equal 17 by 4 root 17. You getting full marks for that? Why?
There's a radical in the denominator.
You've got a radical in the denominator. So you got to multiply by sorry, I'm out of room. As you probably are. So I got 17 root 17 over 4 times 17, which is? Okay. That's cosecant theta. I haven't done this in a while. I didn't realize how much space it needed. Okay, final part here. Find theta to 1 decimal spot. This you would need your calculator for. Not a great question for the test in relation to everything else, but you can find it now, right? Theta is going to equal sine inverse of 4 root 17 by 17.
Side degree and point positive in 1 decimal place.
Yeah, to 1 decimal. So what is it, Gabe?
I'd say 76 then because it's 75.96.
All right, that's
So
good.
how much is it?
0.0.
0.
Okay, why don't you take a second? I'll do this one separately. Okay, but take